Hey guys, welcome to Unit 7, Section 7, which is using trig ratios to find angles. So for this part, we're going to do things a little different. You have to think about what is an inverse operation, because that's what we're leading into. So if you look at these first few problems, the inverse of multiplying by 3, when we have 3x equals negative 27, is to divide. So what we do is we undo the multiplication by doing the inverse operation. We get x equals negative 9. Same thing over here, we would add 6 to both sides. We would get 21 because we would do the opposite. So you get the idea. But going on, what do we do when we have cosine of an unknown angle equal to a decimal? Now remember, each of these decimals, it would be two sides of a triangle because it's a ratio that it's equal to, but it's just the actual sides divided and simplified into a decimal. So what we can do is if you look at your calculator here, let me clear this out. Go to f of x, and notice we have these right here, the sine to the negative 1, cosine to the negative 1, tangent to the negative 1. Those are inverse trig functions, and what they do is help us find angles. So what we can do, pull this back up here. So we want to find the cosine of cosine of x equal to 0.53. So I'm going to type in cosine inverse 0.53, and there we go. I get 57.99. So that's just a decimal, or excuse me, we're going to round it here. That's just an angle. What it does is it looks at the ratio of the side lengths and gives you the closest angle possible for those. So we can do the same thing with these other ones here. So sine, get a new part here. I have to go back to f of x and hit sine inverse, and then I type in the decimal, and now I get 75.9 degrees. I'm going to do the same thing here with this next one. Go to inverse tangent of 1.81, and we get 61.1 degrees. I'm just rounding to the nearest tenth for these. Now notice, these are all really reasonable answers for angles, especially on a right triangle, because the range of the right triangle should go from 0 to 90. We shouldn't have anything smaller than 0, but we shouldn't have anything bigger than 90 because it's a right triangle, so it already has a 90-degree angle inside of it. So the purpose of inverse trig ratios, we want to find missing angles. In the previous video, we were talking about finding missing sides. So the notation for this is sine inverse, cosine inverse, and tangent inverse with the negative 1 power for each of those. All right, let's try it out here. This first problem, just like when we're finding missing sides, you want to identify the angle that you're using. In this case, it's x. And then think about how do the sides relate to that angle. So 16 is next to it, so that's going to be the adjacent side. And 20 is the biggest side across from the right angle, so that's the hypotenuse. Therefore, we need to use cosine of our angle, which would be 16 over 20. Now, since we're using 16 over 20, that's a fraction, we could find the decimal, or we can just save a step and type this into our calculator without that. So we just need to make sure that we do, this is what we're going to type in. I'll write it down so you can see it. Cosine to the negative 1 power of 16 over 20. We can do this all in one step. So find that cosine inverse, and then 16 divided by 20, and there we go. 36.87. We can round this to, or just 36.9 degrees. And notice, it even has the little degree sign at the end here, telling you that you have degrees for your answer. Okay, I'm going to try one more here. So let's do this one on the left. Look at the angle. Notice we have the side across from it, which would make this the opposite. and then we have the side next to it, which would be adjacent. So if we're doing opposite and adjacent, we have to use tangent. So tangent of x equals the opposite side of 5 over the adjacent side of 19. Now that we know which trig ratio we have, we're going to do the inverse of this fraction, 5 over 19. So we pull that up in our calculator. Tangent inverse of 5 divided by 19, and it looks to be 14.7 degrees. Which again, it should be a reasonable answer because it's within that range. And if you notice, x is the smallest angle across from the smallest side, so it does make logical sense that 14.7 should be the smallest angle. So that's how you do inverse trig ratios. Identify which of the three you're going to use, set up the fraction, type it into your calculator. I would say it's even a little bit easier than finding missing sides.